Now, I'm not going to do all of them, but I will do the ones that you want me to do. So, yes, number 3, I heard for sure. Number 3, what else?
The e-value and the arc cosine.
Oh, yeah, we'll do all of those on the back. And 5 and 6? Love to. Any of the other ones? We're good? Okay, yeah, we'll get to there. We'll do these first. And then for numbers 1 and 2, I asked you for the domain and range. That was for 1 and 2. I don't know if you noticed that. Okay. All right, so let's look at this one. Number 3. So we're going to graph cotangent. And if you're doing great on these, you know, you can work on tonight's homework. That's fine. I have no problem with that. Oh, you know what? Now, the thing you have to remember about cotangent is I do ask you to do 2 full periods. And then you need to remember that the asymptotes for cotangent start at 0 and plus or minus pi over b. Okay. So in this case, those will not be my asymptotes because everything is going to shift pi over 4 to the right. Even the asymptotes do. So what I would do is this. I would count 1, 2, 3, 4, and then this is pi. Okay? This is 0, and 1, 2, 3, 4, this is negative pi. Now, these are not going to be my asymptotes, and it gets really tricky here. That's why I'm doing it in a different color. I'm going to shift everybody pi over 4 to the right, and those are going to be my real correct asymptotes. Now, that would be here, and if you didn't draw in the old asymptotes, you were smarter than I was, because then it starts to get really gross. There. Okay. And then your points would all then shift over too. So cotangent's going to be right in the middle of this. And if you remember, cotangent is going to look like a negative cubic function. So it looks like this, and it goes there and there. And then over here, in the middle would be right here. And then up 1 and over 1 for cotangent. It would, it actually goes through that right there. There you go. Okay? So I start by graphing my regular asymptotes, and then I just shift everything pi over 4. So my real graph is in blue. All right, so that was 3. Let's do number 5 now. So you guys really like tangent and cotangent, huh? No, those are the hardest ones out of all of them. So remember about tangent. Tangent's asymptotes are at plus or minus pi over 2 over b. Isn't that right? Yeah, it's terrible. Okay, so in this case, I would have plus or minus pi over 2 over pi, because that's what b is. B is the number in front of x. So I'm going to flip that and multiply. And so, so my asymptotes are really, sorry, you've been so sick. That's so sad. Our asymptotes are really at 1/2 and negative 1/2. So I'm just going to go to the second tick mark in both directions and call that 1/2 and negative 1/2. 1/2, negative 1/2. Okay? So that means that there are 1, 2, 3, and so I'll count 1, 2, 3, and then I'll draw another one, and that would be at 1. All right, so let's do -2 tangent. So here's tangent. It's going through the origin. Nothing's shifted at all. -2 would mean I'm going to go down 2 and over this way because it's going to look like a cotangent graph. There it is. Yeah. Nobody really likes tangent or cotangent. Yeah.
Why would that absolute be at 1? Why is it 1?
This? It wouldn't be at 1. It would be at 3/2. You are correct. There, thank you. A whoopsie, a woo-woos. Okay, thank you, Cassidy. Yeah, because this is 1/2 to here, so then that would be 1 right there, and then another would be 3/2. Correct. Which is funny because I have that right here on my paper, but I'm not even looking at it. All right, number 6. All right, secant. Whoa, this one has a bunch of stuff. Almost too much, almost. We're going to shift this thing pi to the right. We're going to shift it down 2. Okay. I want to think of the cosine graph instead of secant. But I'm also thinking of the negative cosine graph. So there's a lot going on in this problem. First thing I'm going to do is I'm going to move everything down 2. So I'm going to draw in a new x-axis. Okay. And then I'm going to go with every other. I'm going to go 1, 2, 3, 4. And that I'm going to call 2 pi. There's a lot of tick marks on here. Do they bother you a little bit? Yeah? Yeah, me too. I think I leave them off on the graph. I think on the test. I think I just put in a grid like that and let you do your own tick marks because that's better. Okay, so I'm all set. I'm ready to go. Now, cosine. My normal cosine graph would normally start one up from my x-axis. But I'm at negative cosine, so I would really start one down. But then I need to shift pi to the right. So here is the magical point. Did you put that magical point right there? If you have that point right here at pi -3, then you're set. You're ready to go. All right, the next tick mark, I'm back to 0. The next tick mark, I'm up 1. Over on this side, I went this way. I'm back to 0, and then I'm up 1 again, and then back to the 0. So then I draw the graph like this, and this is not the graph yet, okay? And then I draw my asymptotes in, where they go through the new zeros through the line y equals -2. And then I'm ready to actually finally draw my graph. So some of you went just to here like this and this. That's perfectly fine. I went over here and drew one in over there too, because I'm extra. All right. Now, you are going to have recording. All right, so on the back side, we're going to do 4, 7. 4, 7, okay? And I'm going to go through all of these with you because these are tricky, right? I told you these were going to be hard. You didn't believe me. You said they were easy, but they're not. Here's the things you have to remember. Number 1, you need to know the unit circle in order to do these problems, okay? So let's talk about the unit circle. When you get your paper, I have a blank unit circle there, totally blank. You're going to put in your 3 angles. This is pi over 3, pi over 4, and pi over 6. And then you're going to put your points in, 1/2, start with 1/2, rad 3 over 2, rad 2 over 2, rad 2 over 2. Sorry, these are really gross. And then rad 3 over 2, 1/2. It's really hard on an iPad. Okay? And then I would probably even put these in. This is 0, 1. No, it's not. Yeah, make sure you get these points right. That's important. Yeah, that's 1, 0. This is 0, 1 up here. This is -1, 0. And this is 0, -1. All right, and now we're ready to go. Ooh, almost. You do need to remember the range. The range is the most important part on these problems, these arc cosines and sine inverses and stuff. So for sine inverse and tangent inverse, which is arctan and arcsine, same thing, just a different way to say them. The range is going to be -pi/2 to pi/2. So if you're evaluating an arcsine or an arctangent of a negative number, that means that your answer is going to go in a negative direction in quadrant 4, okay? If you're evaluating the arcsine or arctangent of a positive number, you're going in a positive direction and stopping at pi/2. That's the only place your answers can come from. And then for cosine, do you remember the range of cosine inverse? 0 to pi. Oops, including pi. 0 to pi. And so if you're evaluating the cosine of a positive number, then your answer will go to pi/2. If you're evaluating the cosine inverse of a negative, then you're going to be in quadrant 2. So let's do it. Here we go. Arc cosine of -1/2. You're going to go to the unit circle, and you're going to ask yourself, where does cosine equal 1/2? You're asking yourself this. Cosine of what angle gives me +1/2? Because that's what I have memorized. That's going to be right here at pi/3. Except that I'm taking -1/2. And so I'm going to be in quadrant 2. So in quadrant 2, that would be the angle 2 pi/3. Okay? Someone in my last class was like, why can't you just make it a negative pi/3? Do you know the answer to that? What did I say to them? Why can't you make this answer negative pi/3? Well, what is cosine in quadrant 4? It's positive. So that's why it doesn't work that way. You can't go to negative pi over 3. Okay, here we go, number 2. Arctan, did you memorize this one? Me too. I finally did after all these years. The tangent of pi over 3 is rad 3. And the tangent of pi over 6 is rad 3 over 3. So what would be the arctan of negative rad 3? That would be pi over 3, but since it's negative, my answer is negative. You got that one? All right, number 3. Arcsine of negative 1. I want to go to where the y value is negative 1. Now, let's talk about this. The y value is negative 1 right here. 0, negative 1. If you told me, if you wrote on your paper the answer is 3 pi over 2, you are wrong. You're like, but that is true. It is true if I was asking you to evaluate from 0 to 2 pi, but this is arcsine. Arcsine does not shoot out answers of 3 pi over 2. It's not allowed to. The answer is negative pi over 2. Okay? There's no such thing as 3 pi over 2. It's like saying, pick a number between 0 and 10, and you say 50. I'm like, no, you can't. You're not allowed to. Okay, arcsine is only allowed to have answers from negative pi over 2 to pi over 2. Okay, what's the arcsine of negative 1/2? Well, I know my answer is going to be negative. And where is sine equal to 1/2? That would be at what, pi over 6? So it would be negative pi over 6. Are you getting these a little better? All right, how about the tangent of the arctan of 0? Sometimes, like for this one, it works out nicely where tan, arctan just cancel each other out, and your answer is 0. Okay? If you don't trust that, that's okay. Evaluate what the arctan of 0 is. Arctan of 0 is what angle gives me tangent equal to 0, and that would be right here at the point 1, 0, because tangent is y over x. And so then I evaluate the tangent of 0, and I'm back to 0 again. All right, number 6. Number 6. Ooh, this one's kind of fun if you think about it in an interesting way. Now, if I evaluate the sine of 11 pi over 6, 11 pi over 6 is way over here in quadrant 4 all the way around, okay? And I get a value of negative 1/2 for sine of 11 pi over 6. And then if I evaluate the arcsine of negative 1/2, arcsine's not allowed to go all the way around the circle. It's only allowed to go in a negative direction. So my answer is negative pi over 6. Now, did you notice they're the same angle? Like, well, they're not the same angle, but they're the same, they're coterminal. Ooh, we haven't used that word in a while. That gave me trig bumps. Okay, so you go like this way. It's 11 pi over 6, but my answer is going to be the arcsine, which gives me, yeah.
Where'd you get that negative 1/2 from?
Oh, I evaluated the sine of 11 pi over 6.
Okay.
So if you go to your unit circle and you go to 11 pi over 6, this point right here, see, I just memorized this. It's 1/2.
Okay.
But 11 pi over 6 is going to be in quadrant 4, and sine is negative in quadrant 4. Remember, all saints trust Christ. So that would be negative there, so it's negative 1/2. So I evaluate the inside first, and then once I do that, I take the arcsine of negative 1/2. I get negative pi over 6. You're going to have a whole thing of just doing unit circle too. Did I assign that or no? Oh yeah, you did that in the bookwork. Yeah. Okay, how about the arc cos of the sine of 11 pi over 6? So we evaluated the sine of 11 pi over 6 already, and we got a negative 1/2. Now, where is cosine of what angle gives me positive 1/2? That would be at pi over 3, but this is negative, so I need to be in quadrant 2, 2 pi over 3. And we've already seen the arc cosine of negative 1/2. It's right here. We already got that answer. There it is. And then finally, the arcsine of the sine of 0. So evaluate the sine of 0. So let's go to 0. Here I am. And what is the sine of 0? It's 0. So then what's the arc sine of 0? You're back to 0 again. that one, the arc sine and the sine, since this was in the range already, they just cancel each other out if it's in the range. Yeah.
So if that number is in between, was it -2 pi?
Negative pi over 2 and pi over 2, yes, then it will work every time. So if I ask you, like, what is the arc sine of the sine of pi over 4? There's no problem here at all. You just go like that, and your answer is pi over 4. But as soon as I do the arc sine of the sine of 3 pi over 4, your answer will not be 3 pi over 4. It'll be whatever gives you that, and the answer is still pi over 4 for that one. All right, someone else have their hand up? Yeah.
Could you repeat the intervals for like arcsine and arctangent?
Yeah, they're right here. So your outputs for sine, arcsine, and arctan is going to be negative pi over 2 to pi over 2. If I'm evaluating something that's positive, I'm in quadrant 1. If I'm evaluating a negative arcsine or arctan, I'm in quadrant 4. But cosine, that doesn't work for cosine. Cosine would be 0 to pi. Quadrants 1 for positive and 2 for negative. Yeah.
So cosine would be the only one where you can't just, let's say you have pi over 4, you can't just make it negative.
Put a negative, exactly. Mm-hmm.
So all
Yeah.
the other ones you can.
Yeah. Has to do with sine and tangent are odd functions, and you can do a negative on an odd function, but we'll get to that later. Okay. Now the next one, you may want to draw a right triangle. Great, I think I will. Okay, so for these, what I do is I let u equal arctan of 7 over 8. So really, I want to find the sine of u. Okay? So let's go ahead and get rid of this arctan. We can get rid of the arctan by doing what? And this is good advice in any summer day. You want to tan both sides, okay? So we're going to tan this side, flip, and tan the other side. Yeah, that one, actually that went better in this class. The other class, they didn't even smile. Okay. Note on the video, you can't hear laughter. There was none, but there were smiles. Okay, here we go. So let's go ahead and we'll draw a triangle. We're in quadrant 1 because everything's positive. So we're going to draw u right there. There you are. And we're going to go opposite over adjacent. And then we got to find out what the hypotenuse is, and it's the beautiful square root of 113. Huh. Is that anyone's favorite number? Square root 113? No? Okay. Why does your favorite number have to be a whole number? That's so weird. Yours isn't? Classic. Okay, here we go. Now, let's go ahead and evaluate the sine of u. The sine of u is going to be opposite over hypotenuse. Did you rationalize? No, because you don't need to this year. That's amazing. There you go. I rationalize because I can't stand it. Poor Anthony's sleeping. All right, number 10. Still not feeling good, huh? You haven't bounced back yet? Does that mean you have to take all your finals? How many days were you absent? 5. Then yes. Dang. Even if you have a doctor's note. Even if you like have surgery or something happens, yeah, you're taking them.
How many days is it?
3. You can only miss 3 days. Plus 2 college visits. But your college visits, you have to have you have to have proof that you went to a college visit. The dean has to sign something or something. Okay. Anyways, here we go. We're just going to assume that all variables are positive. That's why I'm in quadrant 1 here. So I'm going to say that the cosine of u is x over 4. X over 4. So x over 4. SOHCAHTOA. Does that help? Did you say SOHCAHTOA a lot in your head? I do too, yeah. All right, so then that means this side would be then the square root of 4 squared minus x squared. Don't tell me that's 4 minus x. All right, so then here's u, and we're going to evaluate the cotangent. Cotangent is going to be the reciprocal of tangent, so that would be x over rad 16 minus x squared. That would be the answer right there. Okay, so questions from the book. Which ones would you like to do? I'm assuming 11 and 12. Yeah? I thought so. 11 and 12. And then someone said something else earlier. What was it? 9? 49. 49. Okay. How about all those unit circles? Did you do pretty good on those? Some of them? Yeah, which ones would you like to do? We'll do a few. whatever, just to review some. Some hard ones? Okay. Let's do like 20, 21, 24. That looks fun. 25. Do you have a favorite? 23. Perfect. What else? Anything else? Towards the end? You know your quadrants, you're good there? Okay. Let's look at number 11. 11 was tricky because we're like, what is this even saying, right? It says the point is on the terminal side of an angle in standard position. So let's talk about that. If I have an angle in standard position, that means that its initial side is on the x-axis and it is opening in a counterclockwise direction. And this is going and it's landing where the point rad 3, 1 is. Well, rad 3, let's say that's rad 3, and let's say that's 1, okay? Rad 3 is bigger than 1. So let's say that our angle is landing right here. The terminal side of our angle, the ending side, is landing at the point rad 3, 1. That's what that means. All right, and we want to find out what this angle is right here. Theta. Well, guess what? This side is rad 3. That side is 1. I have opposite and adjacent. I can set this up as the tangent of theta is opposite over adjacent. Now, maybe you don't recognize this as one of your angles, but watch. Let's rationalize this. See, that's why I think rationalizing is so important. Once I rationalize this, I get rad 3 over 3. Do you know what angle that is? Yeah, you do. It's pi over 6, which is 30 degrees. There you go. Okay? All done by hand. No calculator at all. All right, let's look at 12. 12's a little bit easier because of the point they gave you. They gave you that the terminal side of your angle, so here's your angle, the initial side. The terminal side lands on the point -1, +1. So here's the angle that they want you to find. You don't need any trig for this. You just need some geometry skills, right? To here is 90, and then to here is how much? Do you know? 45. If this is 1 and this is 1, that is a bisector of that angle. So that would be 45. So what's 90 plus 45? Oh, it's 135. How many radians is that? You know, 3 pi over 4. Okay? So I didn't have to use any trig on that one. That was great. All right, now let's do some of these fun ones. Let's do 20, 21, 23. Let's just do a couple of them. Okay, number 20. I have to find the secant of -135. I don't like it when it's in degrees. I'm not a big fan. This is all non-calculator. I need to know where -135 is. Well, -135 is going to start here and it's going to end right here in the middle. Okay, so the reference angle is really pi over 4. And I know that at pi over 4, it's rad 2 over 2 and rad 2 over 2. Okay, so the secant is going to be negative, and it's going to be the reciprocal of cosine. So if you left your answer like that, that's fine. The book rationalized it, and they did -2 rad 2 over 2, and then the answer is just negative rad 2. So either way, if you had that or that, great. All right, let's look at 21. 21. Sine of 5 pi over 6. Here's how I evaluate all of these unit circle problems. I look at the reference angle, which is just pi over 6, and I go to quadrant 1, which I have written down on my paper. When I get my test, I will write that down. And I know that at pi over 6, the sine is 1/2. Okay? Now I have to determine, is it going to be positive 1/2 or is it going to be negative 1/2? So I look at the entire 5 pi over 6, that's 5/6 of a pi. A whole pi is half the top, or it's the whole top, it's half the whole circle. And then I know that I'm in quadrant 2, and I know also that all saints trust Christ, so sine is positive, my answer is 1/2. It's a lot, huh? Do you do it that way? Or do you have it all memorized? Some people memorize the entire unit circle. I can't. I don't even know half your names, so I cannot memorize stuff. That's a joke. I know most of your names. Okay. Yes.
Could you write down like I don't know how to explain it. It's like when it's a 45-degree angle, it's like 1, 1, rad 2.
Oh, yeah. That's how you do it? I don't. I don't even know those. Do you? So if this is 45 or pi over 4 or whatever, 45, 45, 90, it's 1, 1 and rad 2?
Yeah, and then
Yeah, then the 30, 60, 90 triangle. Okay, so this is 30 and this is 60. What was it? Across from 30 is 1, 2, and rad 3. There you go.
and what if that one's 60? What if they're switched? The 60 and the 30.
Well, the rad 3 is always across from 60.
Okay.
Because the 31 is smaller than rad 3.
Okay.
So, yeah, so if you're going to evaluate the cosine of 60 degrees, it would be adjacent over hypotenuse 1/2, which on the unit circle gives you 1/2 also. That's why I love the unit circle so much. But you can use those. Go ahead. Just remember which quadrant you're in when you're doing those. Okay, and then 23. Here comes 23. Let's do secant of negative pi over 3. All right. So when I'm evaluating this, I'm not thinking secant. I hate secant. No offense, secant. I'm sorry. I'm thinking cosine of negative pi over 3. And then I'm just going to take my answer and flip it. So I'm in quadrant 4, and I go down here to negative pi over 3. I know that that has a cosine value of 1/2. And it's positive because we're in quadrant 4. So the cosine of negative pi over 3 is 1/2, which would make the secant equal to 2. Okay, take your time on these, okay? They're right or wrong. There's no partial credits on these. Even if you wrote -2, I mark you off completely, okay? They're right or wrong. You have to be exact. It's positive 2 is that answer, okay? That's what, yeah. Ricky, you don't like that? No? Yeah, okay. Something else? Okay. Everything? 49. Last one. We got 10 more minutes, though. 49. We'll see if there's anything else you guys want to go over. It says point P is on the terminal side of an angle. Evaluate all 6 trig functions. Yay, 6 problems in one. That's exciting. All right, yay. -3, 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay, this is not going to be your unit circle stuff, all right? So here we go, and we're going to draw a triangle in quadrant 2 now. And this is really theta prime. It's our reference angle. We can use it, though. We're finding the sine and cosine and all that of that angle, but we use the triangle, and it's going to give us the same values. So -3 is this side. 6 is that side. What's the hypotenuse? It would be just 9 plus 36, rad 45. But you need to rationalize that. This is 9 times 5. So our hypotenuse is 3 rad 5. So when you go to evaluate all 6, here we go. We're going to do the sine of that angle is opposite over hypotenuse. Okay, I hope they wrote that as 2 over rad 5, or at least 2 rad 5 over 5. Cosecant is going to be the reciprocal, so rad 5 over 2. Cosine of the angle is adjacent over hypotenuse, or -1 over rad 5. Secant is negative rad 5. Tangent is opposite over adjacent, -2. Cotangent will be the reciprocal, -1/2. Okay? So you set up a triangle and do SOHCAHTOA.